Hello, Cloud on Air Korea. My name is Akhil Jarawala. I'm one of the product managers here at Cloud SQL and on the databases team. I'm very excited to be here with you all virtually. The subject we're going to talk about today is Cloud SQL in the enterprise. When you bring your data to Google Cloud, you have choices to make about where you want to host your databases. I'll be telling you more about how Google Cloud SQL might be a fit for your databases in the enterprise. We have a lot to cover here today. In today's session, I'm going to start with an overview of Cloud SQL. I'll tell you a little bit about how we help keep data secure in Cloud SQL. I'll share with you what you can do to protect your data in Cloud SQL against user error and system incidents. And we'll finish up by talking about how you can migrate data to Cloud SQL. So first, let's start off with an overview about what is Cloud SQL. Cloud SQL is a fully managed database service that makes it easy to set up and administer your MySQL, PostgreSQL, and SQL Server databases in Google Cloud. Compatibility is at the heart of everything we do at Cloud SQL. Our true north is that if your database is a MySQL or Postgres or SQL Server database, and your application relies on a database that uses one of those engines, it will work in Cloud SQL. Now, maintaining a database is no simple task. There are a lot of layers of technology that have to be managed to keep the database running smoothly. On the left side here, you'll see that we have items related to managing the physical hardware that comes along with databases. That's things like managing power, cooling, racking and stacking servers. All of these items are items that get taken care of for you when you bring your databases to Google Cloud. At Cloud SQL, we offer the flexibility to add on more cores or more gigabytes of memory, increase your disk storage with the click of a button. We take care of what's happening with the hardware underneath so that your application doesn't need to worry about any of that. Moving over a column to the right, we have handling the operating system that runs the database. Cloud SQL handles installing the operating system and updating it regularly to make sure that your systems are secure and functioning at peak performance. In the next column, we have the databases level. And similarly, Cloud SQL handles installing the database, patching the database regularly with the latest bug fixes and performance improvements, and importantly, taking backups of your database so that your data is protected in the event of an incident. Finally, on the right side, we have items related to managing systems of databases. That's things like scaling your database out and managing high availability. Cloud SQL handles replication from one database to another, which makes it really simple to add read replicas in order to scale out or add a standby instance to fail over in the event of an incident. We'll cover this a little bit more later on in this section. Finally, we take care of monitoring. We wrap all of this technology in a lot of tools so that we can determine exactly what's happening on your database when something goes wrong, so we can figure out the root cause and get your databases up and running normally as soon as we can. Tim Kelton is a customer of ours. He's a cloud architect at Descartes Labs, and he found that Cloud SQL had benefits that extended just beyond database administration. Tim says, Cloud SQL gives us more time to work on products that provide value to our customers. Tim found that leaning on Cloud SQL to take care of some of the more mundane aspects of database administration gave his team more time to work on what they were really good at and really passionate about, which is building great products so that his customers could get the most out of Tim's team's time. Let's talk about keeping data secure in the cloud. We know that when enterprise customers move to Cloud SQL, security is of the highest importance. And they know that they're choosing Google because Google prioritizes security above everything else. In our eyes at Cloud SQL, this means starting with having secure mechanisms for how your users connect to the database. They have, in general, two main options for connecting to databases. Users can connect to the database through public IP or the public internet, or alternatively, they can connect via private IP, in which only other resources in that Google Cloud Project Virtual Private Cloud, or VPC, or other authorized VPCs are able to connect to the database. Now, Cloud SQL offers a couple of different mechanisms for authorizing network access to the database. Let's take public IP first. Cloud SQL offers an allow list that allows for the user to specify which IP addresses are allowed to connect to the database. We recommend coupling that with SSL or TLS encryption to make sure that any data sent over the public internet is secure and locked down. For enterprises that are able to use private IP, which is the most secure way to connect to the database, we offer cloud VPC controls that allow you to set firewall rules to stop any unwanted network egress traffic. For enterprises that connect via public IP, we've talked a little bit about authorizing IP addresses, but we actually have a tool that can make connecting as secure as possible, which is the Cloud SQL proxy. The Cloud SQL proxy is an installable agent that you can install on the client that handles connecting to the Cloud SQL database. The Cloud SQL proxy looks local to the application. So just as if you were to connect to a MySQL database running on your laptop, you might connect to localhost. So too do you do that when you're connecting to a database on a client using the Cloud SQL proxy. A big benefit is that the Cloud SQL proxy handles the authorization of the user to the database, so you don't need to worry as much about managing firewalling or the SSL certificates, because the Cloud SQL proxy takes care of that for you to make sure all of your application traffic is vetted and secure. We've talked about authorizing traffic to the Cloud SQL database, but how about just authenticating to the database itself? Often, access to databases is controlled simply with a local username and password. But as any information security professional knows, passwords are oftentimes the weakest link in the security chain. Ensuring passwords are unique, sufficiently complex enough, and rotated frequently enough can be painful for IT administrators, especially when you are managing passwords for multiple databases and multiple systems. Identity and Access Management, or IAM-based database authentication, takes care of this by allowing for users to log in with their main GCP user account credentials. So how does this work? Effectively, a user first logs into Google Cloud with their Google Cloud username and password. Once they're in, they request an access token from the IAM service. They take this token and they present it when they're attempting to log into the database using G-Cloud, for example. In the back end, we take a look at that token, we verify that the user is who they say they are, and we allow the user to log in to the database. The tokens are specific to Cloud SQL and they are only valid for an hour. So we can ensure that the access is restricted and that the user can access the data securely and safely. Of course, securing connectivity to the database is just one part of having a strong security environment. What about actually protecting logging in successfully to the administrative components of the database? A good security posture is knowing which administrators have access to the database, when they are touching the database, and what they are doing while they're using the database. And that's really where Cloud SQL shines. We have a number of tools that allow for an organization security administrator to define who can connect to the database and what they're allowed to do with the database. Additionally, we have VPC services control, which protects the Cloud SQL administrative API by putting a perimeter around it. It gives administrators an extra level of context control by defining from where users are allowed to use the administrative API and take administrative actions on the database. So once you've restricted access to the admin API to only those who need it, it's still important to have visibility into what those administrators are actually doing. Cloud SQL integrates with cloud audit logs for this reason, so that teams know exactly who did what, where, and when. Altogether, Cloud SQL keeps data secure and provides security teams with full control and access to information about who is using the database and how they are using it. Let's talk some about protecting data in Cloud SQL. How do Cloud SQL users protect themselves from data loss and recover their database back to normal in the event of an incident? You know, in presentations like these, oftentimes we depict incidents with icons looking like fire or earthquakes. And in practice, the most common incidents are not natural disasters like that. They tend to more often be related to human error. It's far more common for IT environments that we need to connect to recover from a simple mistake that somebody made. Perhaps a user accidentally drops a table and doesn't realize it until hours later. In that case, we need to undo the change and recover the database back to normal. Cloud SQL offers both automated and on-demand backups of the data on the database instance taken at a point in time. So how does this work? By default, Cloud SQL takes one backup per day. The user defines what 4-hour window during the day do they want those daily backups to be taken, as well as the location to store the backup. That can be particularly important in the enterprise if there are data residency regulations that we need to comply with. Finally, users are allowed to set a retention policy to define how many days of backups they want to keep. Cloud SQL allows for users to keep up to a year's worth of backups. Some customers ask about the costs associated with keeping that many backups. What's important to know is that Cloud SQL backups are block level backups. That means after the first backup is taken, each subsequent backup only captures the changes at the block level. So in other words, the size of the backup depends on the amount of activity on the database, not necessarily on the amount of data that's in the database. And that can be important when you're thinking about things like cost. Backups are a really good start, but they only get us so far. While backups do bound potential data loss, in the event that we need to recover from an incident, we might still miss up to 24 hours of transactions that have occurred since the most recent backup. So how do we do better than this? This is where point-in-time recovery comes into the picture. Point-in-time recovery builds upon backups by allowing us to set a point in the timeline that we want to recover to down to the second. Let me give you an example about how this works. Let's say that I'm doing an administration task on the database and I accidentally drop a table. And let's say I don't realize it until hours after the fact. When I realize that this mistake has been made, I can go to Cloud SQL and I can tell Cloud SQL to recover my database by creating a clone that is fixed to a particular point in the timeline. So the copy of the data is fixed to an earlier state. I can then go back to my application or the database logs and determine at what point in time, down to the second, did the mistake occur. I can take 1 second away from that and indicate to Cloud SQL to what point should I restore the database to. What we do then is under the hood, we find the most recent backup that occurred prior to that point in time. And then we replay the transactions up until the second that you tell us. At that point, a clone of the database is created. And what we can do is find the data that's missing, export it from that database, and import it into the working database. At that point, we've fully recovered. Cloud SQL supports point-in-time recovery up to 7 days in the past. Of course, sometimes things go wrong with the systems, and some situations extend beyond human error. Of course, technology systems fail from time to time. Many of you who work with IT systems know that high availability can be difficult to achieve in practice. It typically involves having multiple databases, so redundancy of the data, some kind of workflow mechanism, and health checking to make sure you can determine when the original database you're using is starting to suffer from some issues. Now, let's say there is an outage in Zone A, and the primary is affected. If I have a high availability configuration with Cloud SQL, a few things happen. The first thing is that we have a health checking agent on that primary instance that we no longer hear from in the Cloud SQL platform. And at that point, we might know that something is up with the data. If we haven't heard from the health checking agent for a long enough time, we begin a workflow that moves over the database from Zone A to Zone B. What's happening is we take the static IP address that's affiliated with the primary instance in Zone A, and we move it over to a standby instance that's sitting in the background in Zone B. At the same time, we take a regional persistent disk that was connected to Zone A, and we connect it to the standby instance in Zone B. What's important about the regional persistent disk is that when things were working normally, Cloud SQL was writing data not only to Zone A, but with synchronous disk replication, a copy of the data is also been written to Zone B. That means that when we fail over the database to Zone B, the copy of the data is available in that zone already. And we're able to get a full and complete recovery of the data down to the very last transaction that committed successfully from Zone A. One thing that I wanted to mention is that from the application's perspective, because we've moved over the IP address and the name of the Cloud SQL instance, the application doesn't need to know that there's been a change in the database instance underneath the hood. From the application's perspective, all that's happened is that the database has gone down for a moment. When the application attempts to reconnect to the database and it reconnects successfully, it can continue writing to the database just as it was doing before, and the database will continue to serve the application as normal. This time, it's just from Zone B instead of from Zone A. Let's round out by talking about recovering from disasters. Enterprise IT professionals spend a good deal of time planning for recovering from disasters because these events can be very difficult. At Cloud SQL, we tend to think about a disaster as a regional outage. What does that mean? A regional outage is when multiple zones in a region, or maybe even all of them, lose connectivity or are down at the same time, such that the entire region is down. As you can imagine, a regional outage can be very disruptive and have significant consequences, just as any disaster would be. Maybe you have multiple applications that are down at the same time. In that case, the number one priority is to recover the systems as fast as possible while losing as little data as possible. Let's take a look about how Cloud SQL has made this a little easier. We use cross-region replication to help guard against regional failure by setting up a near real-time copy of the data in another region. Now, this other region is different from the original primary region you're hosting your data in. In the event of a regional outage, all that you need to do is promote this near real-time copy of the data, the cross-region replica, to become a primary, and point all of your application traffic to this new instance, and you'll be up and running back to normal. One important thing to highlight is that because Google Cloud's VPCs are global in scope, setting up another read replica in another region is as little work as setting up a read replica in the same region. There's really no additional networking configuration that needs to be performed. And better still, data can be sent from the primary instance to the cross-region replica within the same project using private IP, ensuring that all of the traffic is secure and kept off the public internet. The last thing I wanted to mention is that keeping data protected and keeping systems up and running takes a team effort. Cloud SQL Enterprise customers get the help they need from a customer care team that is distributed around the world and available around the clock to respond to important incidents. When there is a problem that demands deep expertise, the Cloud SQL Site Reliability Engineering Team, or SREs, is available to help. They're the team that writes the automation that is used to keep Cloud SQL systems and databases healthy and running normally. However, from time to time, when the situation demands it, these are the folks that get on keyboards to make sure that the problem can be resolved and the database come back to life. Our support team is an experienced group, and they've tended to tens of thousands of enterprise databases. So it's great to know that their hands are available to help when the situation arises. Jason is a CTO at Real Massive and is one of our customers who acknowledges that the comfort associated with having these safeguards and having the SRE team has been among the biggest benefits of coming to Cloud SQL. Jason says, the peace of mind provided by high availability and Cloud SQL's SRE team, combined with the reduction in operations, makes the decision to move to Cloud SQL a simple one. Let's finish up by talking a little bit about migrating over to Cloud SQL. You may have had to move a database to another server before. Maybe you were moving from an on-premises environment to the cloud, or potentially from one major version of the database to another. If that's the case, then you know that database migrations are no simple task. You may have needed dedicated servers to conduct the migration. Potentially, you needed to figure out how to securely send data from the source database to the target. Potentially, you needed to figure out a workflow to validate the data arrived accurately and on time in the new target database. The most important thing about these projects is that business has to keep running while migration is happening. Coming up with a plan for minimizing the downtime is essential to a successful migration. Last year, Google Cloud announced a new service that simplifies the migration job. The service is called the Database Migration Service, or DMS. DMS is a tool that many enterprise customers have used to move their data to Cloud SQL. And they've used DMS to move their data from multiple different source environments. Some of them are coming from on-premises environments to the cloud. Others are moving from other public cloud platforms to GCP. And still others are moving databases that they were self-managing in Google Compute Engine over to Cloud SQL. DMS supports a continuous migration path to Cloud SQL. And what that means is that the database is not available during the migration for a very small amount of time relative to the entire migration process. DMS makes the migration task itself simple. There are no migration servers to manage, and the baked-in configuration wizard walks the user through the steps of identifying a connection profile for the source database, creating a target database or a destination database in Cloud SQL, identifying the connection method, and testing the migration is successful. To ensure that data is secure while it is being transferred, DMS supports multiple connection options that use encryption or private IP. How does this work in practice? Well, first, DMS takes an export or a dump of the source database and imports that into a new Cloud SQL destination database. What's important to know about this is that this process happens while the source database is still serving application traffic. At this point, the application is talking to the source database just as it was before the migration job was started. Now, this process to dump the data out of the source database and import it into the destination database can take a while. And for particularly large source databases, this could take hours. But what's important to know, as I said, is that since the source database is still talking to the application database, the database is still available to serve traffic for the application. Next, once the import has finished in Cloud SQL, we begin to catch up using replication. All of the changes that were committed to the database while the dump and import were taking place have to make their way over to the Cloud SQL instance. Again, if the activity on the database during the dump and load was significant, this can also take a long time. But again, as we said before, the source database is still serving the application. Once the Cloud SQL database has fully caught up to the source database, that's when we begin the final step for migrating, which is disconnecting the application from the source database and pointing it to Cloud SQL. This is the point at which the database becomes unavailable to the application. However, this doesn't need to take all of that long, because all we need to do is point the application to Cloud SQL. Since this is the only part of the migration process when the database is not available, the outage period in a continuous migration is substantially shorter than it would be if we were to stop the database at the very beginning and only start it at the very end of the process. Christopher is a principal engineer at Freedom Financial, and he was involved in migrating some of his company's databases from a monolithic setup to microservices in Cloud SQL. Christopher says, initially when planning the migration, we figured that a planned downtime of 2 to 3 hours might have been workable. With DMS, the actual downtime for each application from the database's side was a maximum of 10 minutes. This was a great improvement for every team in our organization. DMS gave Christopher peace of mind knowing that getting to a place where Cloud SQL could be the foundation of his databases would be a manageable endeavor. We've covered a lot of ground in this session. We talked about how Cloud SQL is Google Cloud's managed service for MySQL, Postgres, and SQL Server. We shared a little bit about keeping data secure using the Cloud SQL proxy and other administrative tools. We touched on how Cloud SQL users use point-in-time recovery, high availability, and cross-region replicas to protect themselves against an incident involving user error or a system going down. Finally, we finished by talking about how the database migration service makes migrating to Cloud SQL easy with minimum disruption. I hope that you have a better understanding now of how Cloud SQL can fit in with a modern enterprise.